Good day, viewers. This is Avogadro Johnson, your chemistry tutor and your biology tutor. Yes, don't forget to subscribe, share this video, and like it. In our previous video, which you are advised to go and watch now, we have done video on the stoichiometry of masses, stoichiometry of volume, stoichiometry of number of moles. Now let's look at stoichiometry of number. What is number? Stoichiometry of number can be number of ion, number of molecule, or number of atoms. Stoichiometry of number of ion, number of molecule, and number of atoms. Take note of one thing. Now, the number of ion, atom, or molecule is equal to number of mole times Avogadro's number, where Na is Avogadro's number. Which is 6.02 times 10 to the power 23. So when we say number of mole is the amount of the substance that contains as many elementary entities, that elementary entity that is present in a mole is in Avogadro's number. There is one why they say define Avogadro's number. So Avogadro's number. This is the elementary entity in 1 mole of any substance, as there are atoms in 12 grams of carbon 12. So that is Avogadro's number by definition. Avogadro's number is as many elementary entity that is present in 1 mole of any substance. That's Avogadro's number. Now, we are moving on to look at, and we are giving you, now in this place now, I just told you that the number of any particular substance is the number of mole times Avogadro's number. So, and I've given you the various formula for number of mole. So that means you can also have, so from there, considering the various formula for finding number of mole, we have the following formula for finding number. These are, number 1, since number of mole is what? Mass. So number can have number equals to, see, number of mole is mass over molar mass. Then we can multiply by 6.02 times 10 to the power 23. 6.02 times 10 to the power 23. So that's number 1. Okay. And we can also have number equals to, we also know that number of mole is volume over molar volume. Also multiply by 6.02 times 10 to the power 23. We have calculated number. Another one is number is equal to CV over 1000. Don't forget CV over 1000 is also number of mole times 6.02 times 10 to the power 23. Then number 4, we have number is equal to CV, ordinary CV, times 6.02 times 10 to the power 23. So all of these are the various formula for calculating number of ions, number of molecules, number of particles. So let's look at examples. Number 1, find the number of atoms in 1.8 gram of aluminium metal. Then they will now give us two things. Al is 27, then Na is 6.02 times 10 to the power 23. Yes. If that is the case, solution to this problem, our number of atom now, will now be equal to mass of aluminium over molar mass times 6.02 times 10 to the power 23. So, and this gives us, what is the mass giving? 1.8, right? 1.8 gram over molar mass. Aluminium is Al, that's 27. Why will not multiply it by anything? Aluminium, its name ends in ion. Any element whose name ends in ion, they are monoatomic elements. Then times 6.02 times 10 to the power 23. So what do we do to get that? We have 1.8 divided by 27. We have 0.066. Now times 6.02 times 10 to the power 23. So we now multiply 0.066 or 67 now times 6.02. What do we have? We have 0.40 times 6.02, times 10 to the power 23. Now, we can convert this up to a standard form. Move this point to this place. You have 4.0 times 10 to the power minus 1. You have moved 1. Then times this 10 to the power 23. And this same thing as what? 4.0 times, choose one out of this, minus 1 times changes to plus 23. And this gives us 4.0 times 10 to the power 23 minus 1. So and this gives us 4.0 times 10 to the power 22 atoms. So whatever thing they ask you to find is the SI unit. Find the number of atoms. And if they say find the number of ions, that's what we are getting there. Let's look at example 2. Find the number of hydrogen ion. Find the number of hydrogen ion in 0.8 mole 0.8 mole per dm cube of H2SO4. Let me use another one. HNO3 in 300 cm cube of the solution. Now, then I'll be giving Na equals to 6.02 times 10 to the power 23. This Na is Avogadro's number from behind. Okay? Now that we have that, what do we do? So next thing to do is to write our formula. This one, our number of hydrogen ion. Is equal to CV over 1000 times 6.02 times CV over 1000 times 6.02 times 10 to the power 23. So what's our C? Any number that carries mole per dm cube or molar, which is what? 0.8. 0.8 represents this C. 0.8 times, what's our V? Any number that carries cm cube at the back. That's 300. Now over, let me minimize space. 0.8 times 300 over 1000, then times 6.02 times 10 to the power 23. So what do we have here? We have 0.8 times 300, then divided by 1000. Then we have 0.24. Then we have times 6.02. Then times 10 to the power 23. So let's multiply this. We have this one times 6.02. Our answer here is 1.44. Now, down times 10 to the power 23. It's already in its lowest term. Then we have what? Now, but since the basicity of HNO3 is 1, then you leave it like this. And if the acid is H2SO4, where the basicity is 2, you have to multiply this number by 2 to get the number of hydrogen ion. So this is ion. Take note of that. If the acid is if the acid is H3PO4, you have to multiply your answer by 3 by the basicity. So you are leaving it like this because anything times 1 is that thing. Now example 3. Find the number of molecule find the number of molecule in 0.3 mole or molar of Na2CO3 in 3.5 dm cube of the solution. Then you are giving Avogadro's number equals to 6.02 times 10 to the power 23. When you have this, what do? Now let's come back here. Yes. What do you do when you have something like that? Don't forget here, number is equal to what? Is equal to ordinary CV. Why? Because the volume is in DNQ. Then times 6.02 times 10 to the power 23. So our C now is what? Is what? Is 0.3 molar times, what's our volume? 350, 3.5, then times 6.02 times 10 to the power 23. Then what do we have? We have 0.3 times 3.5 times 6.02. Our answer now is what? 6.321 times 10 to the power 23. Now, what is the unit? Molecules. Now, because we are asked to find the number of molecules. Yes, let's go on. Another example here, example 4. We are asked to find the number of molecules of 152 cm³ of ammonia. Ammonia gas. Then you have molar gas volume equals to 22.4 dm³, and Avogadro's number equals to 6.02 times 10 to the power 23. So what do we do here? Our formula remains number equals to, what's the number of mole? What is it? When you have volume, that's volume over molar volume times 6.02 times 10 to the power 23. So what's our volume according to this question? 152 over, the molar volume is in dm³, but I want it to be in cm³. What do? I multiply by 1000. 22.4 times 1000. Then everything times 6.02 times 10 to the power 23. So you can even finish it up here. This one becomes 152 over, this one is 22,400. Then times 6.02 times 10 to the power 23. Then we press our calculator. We have 152 divided by 22400. We have 0.0068, then times 6.02 times 10 to the power 23. Now let's use this to multiply this. We have 0.0068 times 6.02. Our answer is what? 0.041. Then times 10 to the power 23. Why are we not leaving our answer like this? Don't leave your answer when you have 0 point something. So your point must be between the first number. So when we move 1, 2. So this one is the same thing as 4.1 times 10 to the power minus 2. Then we also have 10 to the power 23 here. Then what do we have? This one is equal to 4.1 times 10 to the power, choose one out of this, minus 2 times change it to plus 23. Then this one is as 4.1 times 10 to the power, write the 23 first, then write this 2 second. And this gives us 4.1 times 10 to the power 22. 22 what? What is our answer to find? Molecules. molecules. So now that is that. So that is all we need to know about number of ions, number of molecules, and so on and so forth. So we are drawing the curtain in this place. Watch out the next video where we are going to be talking about concentration of the solution and preparation of standard solution, and where we'll be talking about primary standard and secondary standard, talking about dilution formula. In the next class we will do that. Okay, I remain my humble self, Avogadro Johnson. Don't forget to subscribe, don't forget to share this video, don't forget to do what? To like it. Just like I love you, I'll see you at the top. See you next time, as God be with me and be with you in the next class. God bless you, and bye for now. Thank you.